presentation grade is actually subjective. Now, if you end up at an 85 dead center, you know, I probably don't need to look back. But if you end up, you know, right on a borderline grade, then I go back and I look through those presentations and I try to determine what notes I made in here. Like, you know, was that one of the theorem? Was that one of the proofs? Was that one of the harder ones? Because maybe you have less presentations than somebody else, but you've done more impressive job presenting them. Or maybe you've done maybe you've just done the harder problems in the course. So that's when I look back and I say, well, that presentation grade should be a little bit higher, this, that, the other. The other thing I look at is the final, because the final is comprehensive. And so if your test scores were 60, 80, 95 on the comprehensive final, and your average is an 88, I'm going, made an A on the comprehensive final, I think they're going to do fine. You know, I think they're an A student. So I reserve the right to bump your grade based on multiple criteria. But the worst thing I do is average the 3 tests, give you a presentation grade, and glue those two together and divide by 2. Other questions for me?
What in the world are we learning today?
What are we learning? I thought you were going to teach me something. You didn't do any problems for me?
I haven't.
You took last night off?
I did. Actually, I
What
did.
a bunch of
I enjoyed last
slackers.
night. I had my physics test. And
What
I
a bunch
took it
of
off.
slackers. I thought after that test you'd be going, man, after I ace that, I'm gonna get some extra work in because I feel so smart. No? That wasn't the feeling?
I'm going to let you lead the way, and I'm going to follow close behind.
So does anybody have anything to present today? Juan's got something. What do you have? What number?
307.
307. Make a note. That's right at the end of Power Series, I'm thinking.
I'll have 307.
Don't have 3. Pardon? Started it, but don't have it. Okay. Okay, well then let me say something about the end of Taylor series there. First of all, so we're going to skip 7.1, which is conic sections. I hate to skip that section because I didn't understand conic sections when I took it as a calculus student. It was just taught, memorize a bunch of formulas for what an ellipse is and what a circle is and what a hyperbola was, and I really didn't understand it. And in fact, parabolas are really neat. You take any line you like, and you take any point that you like. Now, what do you think of as a parabola? If I say, write a parabola on the board, give me an example of a parabola you'd write on the board.
X squared.
Y equals x squared, right. Or if you wanted to be fancy, you'd go 3x squared minus 2x plus 5, right? You think of it as an equation. But a parabola historically doesn't come from an equation. Historically, a parabola comes from the following geometry. You give me any line, you give me a point. Now, can you find me another point that's halfway? Can you find me another point so that the distance from the line to the point equals the distance from that point to this point? I'm going to call this point F. And this line L. So I want to know, are there any points Q so that the distance from Q to L is equal to the distance from Q to F? Are there any points such that the distance from the line to the point is the same as the distance from the point to F?
Yes.
Yes? Can you tell me where one would be?
Along a parabola.
So where would one be?
The mirror image.
The mirror image, the distance from this, if I put this point over here, so the distance from this point to this line is that distance. The distance from this point to that doesn't look the same. That looks like it's twice as much as this, doesn't it? So the distance from this point Q to the line looks like it's half the distance from Q to F. I want them to be equal. What about what? Like up here? So this distance from the line would be 0, and its distance from F doesn't look to be 0.
Between the point and the line.
How about between the point and the line? Like here?
Or like half the center.
Halfway in between? Don't you hate a facetious teacher?
What's facetious?
That point. So do we all agree that that point, the same distance from the F as it is from the line? Yeah. Are there any more? Well,
You go up.
I,
Anything on that line that's parallel to the line.
this? Well, that distance doesn't equal that distance, does it?
Could you double that? Could you like make the point?
Out here?
Yeah.
Is this distance equal to this distance?
We can make a right triangle.
Okay, so the answer is, there are infinitely many such points. Let me see if I can draw another one for you. Let's see if I can draw another one. The distance from the line, I think this point, I think that distance is equal to that distance. All right, it looks like maybe I need to go a little bit higher. Yep, that distance and that distance are the same. And if that one works, then one just opposite over here should work too, by the same logic, right? Now suppose I want to go up along this line, somewhere on here. Do I have to go higher or low? Well, let's see, this one doesn't work, right? That distance doesn't equal this distance. But somewhere up here, this distance and this distance are the same, right? That distance and that distance are about the same. Now, so there are infinitely many points that satisfy that. That's actually the geometric definition of a parabola. So, you know me, I don't understand anything until I can figure it out 2 or 3 different ways. The geometric definition of a parabola given a line L and a point F, the set of all points Q satisfying the distance from Q to L is equal to the distance from Q to F is called the parabola determined by F and L. L is called the directrix. F is called the focus. So every conic section actually has a really neat geometric definition that you never see and you never think about in algebra because you're always thinking about the equations. You're always thinking about them as formula. So even though we're going to skip conic sections, I thought it was worth spending 10 minutes to talk about the beauty of the geometric definitions and how you can go from this geometric definition and show that the parabolas can be written in that this is the type of form they take. That's not actually the easiest thing in the world to do, but my notes walk you through that if you ever decide that you just can't stand to not understand conic sections. I know that happens to most students at some point in their life. Ellipses are easier, right? Parabola? determined by F is called the parabola determined by F and L. So you give me any line and any focus, and what happens if you make the line farther away or really close, you get a really fat parabola. But if you make the point really far away, you get a skinny parabola. Right, how far it is from the line. So you can see that's why it gives you all the different parabolas that you're used to.
Can you find a focal point from this y equals? How difficult would that be?
The answer is yes when you start, but you have to get smart and write it like in a more clever way. Some constant times x minus h squared plus some other constant. So you want to write it in a slightly different way. And that's kind of what they teach you when you memorize the stuff. If you open Stewart on conic sections, it'll say, take a parabola, write it in standard form. From this standard form, you can now get the directrix and the focus. So yeah, you can go from here to a clever way to write it. And I can't even remember how to do it off the top of my head. I'd have to go back to this formula and derive it to be able to do that. But you can do it just like that. Just like, you know, there's a way, if you talk about x squared plus y squared equals 9, you know that's the circle of radius 3, right? That's a conic section. Why do you know that? Because every circle can be written like that. Oh, well, that's not every circle. That's every circle centered to the origin. Now, if you want every circle, you need to write it like this. And now these three things have meaning, right? HK is the center, and R is the radius. So if you take a circle, if I give you something like, well, I can't make one off the top of my head, I'm not that good. If I rewrite that in some non-standard way, you can always come back, right?
X minus h.
To the standard form, and once you get it standard form, you now know the center and the radius. And when you look at ellipses, an ellipse, take a board. Any carpenters in here? Take a board, put 2 nails in it. Take a piece of string and tie the string at both ends to the nail. You did this in elementary school? Somebody, at least one person did. Put your finger on the string and stretch it out as far as you can. Go around the nails, and that's what you get. Think of this as, if I took some string here and attached it to these 2 nails, and I took my finger and I stretched it out, it ends up about here. Now if I ran around the nails, what you get is a nice ellipse. So that says, what is an ellipse? An ellipse, you give me 2 foci and a length of string, and that uniquely determines an ellipse. So ellipse also comes from a nice, cool geometric thing. Okay, I won't say any more about something we're not going to cover, but I thought it's worth saying a few words about how all the conic sections come from both geometric and algebraic. When you write an ellipse in standard form, you write it as x minus h squared over a squared plus y minus k squared over b squared equals 1. And this tells you something about this width, A does, and this tells you something about this width, B. And I don't think you want the H. I think I'm lying to you. And then this is assuming it's centered at the origin. Yeah, I guess you do need those if they're not centered at the origin. That tells you the HK tells you the center. So again, if you get it in a certain form, then you know the width of the ellipse, the height of the ellipse, and the center of the ellipse. Anyway, I think it's really cool stuff. Maybe you'll see it in Calc 3, maybe not. Probably not. All right.